Happy Saturday, everybody. I like to choose a slow laptop because it builds suspense. Everybody looking forward to the next Welsh rugby game in 1 week, I guess. Yeah, it's going to be very exciting. So, welcome to this part of the program. So, Stephen talked a little bit about the teaching aspect of computer science at Swansea University and a little bit about the program. The topic here is how computer science changes the world, or in this case, it's how visualization changes the world, data visualization. By the way, if anybody has comments or questions in the middle of the talk, feel free to just interrupt me at any time. I don't mind. Before I start with sort of a discussion of visualization, I just thought it might be worth mentioning who I am, because nobody here knows who I am, well, except for one person. So I joined the computer science department in 2006, which is already a long time ago. Before that, I worked at a place called the VR Viz Research Center in Vienna. Has anyone been to Vienna before in the audience? One person? 2 people. Only 2 people. I highly recommend it if you haven't been there. After this talk, you can get some tickets there. I have a PhD from Vienna University of Technology, and before that I was in the US writing some degrees there. And the areas I specialize in are data visualization, information visualization, scientific visualization, and visual analytics. I mentioned this not only because I enjoy talking about myself, but if you look at the background of all the staff here, it's usually colorful. It's usually a colorful background with an interesting history. So on to the visualization stuff. Why are we here? We're here to talk about Sally's big data quandary. Are there any Sallys in the room? One. Congratulations. This is for you. Any other Sallys? So, tell us how well this reflects your life, by the way. I want some feedback afterwards. I'm practicing my psychic development this year. That's part of the gig. So Sally discovers that she can collect data cheaply. And because Sally can collect data very cheaply, she decides to collect it. So she collects a lot of data, and she collects data over years. Yeah? After a few years of collecting data, she has an urge, a new desire, a new want. She wants to do something useful with it. She thinks, oh, I've been collecting this amazing data for a few years now. It must be valuable. It must be worth something. I must be able to learn something from it. She wants to derive new knowledge and extract insight from the data. As soon as she wants to do that, though, she discovers that it's very difficult. She discovers it's a difficult process to derive new knowledge and insight from the data. So she discovers something that she didn't know about previously. And that's the gap between her ability to collect data and her ability to derive knowledge and insight from the data. So there's a gap there. There are two separate skills, collecting data and deriving useful information and knowledge from the data. And that's something that she wasn't aware of when she started to collect the data. Right? So it's like a magic threshold appears. As soon as the data does not fit on a nice spreadsheet, it suddenly becomes very difficult to manage and derive knowledge from it. This is the first stage of learning, if anybody's interested. This is going from unconscious incompetence, when you're not aware that you don't know something, to becoming aware that you don't know something. Yeah. So Sally, at the start of her data collection process, wasn't aware that there was a challenge there to derive useful knowledge and insight from it. And then she became aware of this challenge. Is it true about you, Sally? It depends on what you do for work. Probably it's true about your employer. So this is not just this Sally here. Sally is a metaphor for everybody, right? This is happening to everybody, everywhere, collectively. So on the left side, in the left column, we have sort of career-oriented Sallys, or people that generate and collect massive amounts of data, like computational fluid dynamics engineers. There happen to be a lot of those at Swansea University. There happen to be a lot of those in the UK. This is actually a very British activity. You might not have been aware of that already. We have lots of physicists and astronomers collecting lots of data from experiments, satellite images, and so on. We have marine biologists and biochemists collecting and generating massive amounts of data. We have psychologists, sociologists, criminologists, right, collecting data, often in the form of surveys. Has anybody here ever filled out a survey before? That data goes into a database. We have sports scientists collecting lots of data. In that case, it's rugby data. So it's in the form of a video. So that is a source of data, actually. We have journalists. We have humanities scholars. Text is also data. So we have a library just next door to us, and that is a very big data set. And we have, of course, another example, councils, like Swansea City Council is collecting lots of data about the people living in Swansea trying to figure out what they're doing. Yeah. That's on a more professional level. On the right-hand side, this is a little bit more personal, a little bit more individual. Right? Every time you go to the bank or go to the ATM, that data is collected and stored. Right? That's a lot of data. Every time you make a phone call, right, that data is collected and stored, right? If you call a call center, all the events that take place in the call center are recorded in a database, right? Every time you go shopping, the data is recorded, right? Even if you don't buy anything, just the fact that you came and went can be recorded by somebody, right? They're all trying to figure out how to get more money from you, right? Every time you look at a web page, the data is recorded, right? It's recorded by at least three different places. The website you visited, they record the fact that you visited their website. The internet service provider records the fact that you visited their website, and usually there's a local administrator that sees what's happening. Right? Transportation, every time you go somewhere, that data is recorded, and so on. I think you get the idea, right? We have healthcare data, and you collect data, right? Some people here might collect selfies, right? You collect photos, videos, files on your computer. This is everywhere and everyone. And it's a consequence of at least two things. Data storage is cheap, and people like to collect. That's just human nature, right? People like to collect. Anybody here collect anything? I know that a lot of you collect things here. Sometimes you might collect something involuntarily, right? I collect bills involuntarily. I collect email involuntarily. I'm always trying to delete it, right? Anyway, it gives people some satisfaction, this idea of collecting things. So let's talk about data visualization. So data visualization is using computer graphics to generate images of large, complicated data sets. And this is one of the big topics in the computer science department at Swansea University. It's one of the things we spend a lot of time studying and researching. So visualization is good for different things. So it's good for exploration, right? This is the case where you might not know anything about a data set. Maybe you're just trying to find out what the data set is, if there are any trends in the data set, if there are any patterns, any outliers, any strange activity. Data visualization is also good for analyzing. This is the case where maybe you're an expert at some topic and you've collected the data with a very specific purpose, right? You have very specific questions you want to answer. Maybe you want to confirm or refute a hypothesis. And visualization is also good for presentation, which is what we're going to use it for starting on the next slide. So this is after the exploration and analysis are done, and you want to present the results of your work to a greater audience, a wider audience. Visualization is also good for acceleration. So we can do some things with visualization. We can accomplish some things with visualization in maybe a few seconds or a few minutes that might otherwise take hours, weeks, or months to do. Or never. Okay, so I have a few different examples, but because of the amazing Six Nations tournament that's happening right now, I'm going to focus on a very special example, which is visualization of rugby. Are there people here watching rugby? How many Welsh people are in the audience? Okay, so there are definitely some avid rugby fans in here. So I think you're going to like this. This is, you can think of this as an alternative way to watch rugby, right? Everybody's favorite sport. So during a rugby game, I've never watched a video of a rugby game, by the way. I've seen rugby games in this alternative form before, but I've never watched a video of a rugby game. Now, watching a video of a rugby game is fun, right? That's why you do it. But what if you are a trainer or a coach or a player trying to improve your game, right? Or maybe, you know, England is about to play Wales, right? And the Welsh want to beat the English, right? And they want to study the strategies of England to try to beat them. Well, what do they normally do? One way to do that is just to sit down in front of the TV with some popcorn and beer, Welsh beer obviously, and watch all the games, right? Watch maybe 10 games, 20 games. That's challenging, right? That's very challenging. And take notes on a notebook, right? It takes a long time, which is why I've never done it myself. It's also difficult to find patterns. Maybe you're watching your third game and you see someone score a try and you think, oh, didn't that same thing happen 2 games ago? And then you have to go back 2 games ago and try to watch it again and find out again. So for those 2 reasons, at least, it's very difficult. Never mind the pain it would cause in your lower back watching 10 or 20 hours of rugby, a physical pain. So we can visualize rugby data. During a rugby game, as you all know, there are people sitting on the sidelines recording data about every event that takes place, right? People getting paid and working hard to record data about every single event, right? So they're recording, for every single event, they're recording gain, how far down the field the team brought the ball, the kind of event that happens, like a line out or a scrum or a turnover or a try, for example. They're recording the territory start position, where the ball started during that point in the game, the number of phases, the direction the ball took, the lateral movement, up, back and forth, the time at which it took place, how long the event took, and which team created the play, is responsible or was in the game. We can map all this data to something visual. In this case, it's a glyph. And this is what it looks like. It's pretty complicated, right? But time and event duration are mapped to this red arrow. If the beginning of the game is at midnight, we can see this is an event that happened shortly after the start of the game. The thickness of the arrow is mapped to how long the event took. Right? So a thin arrow means it was a short event. And then we can map all the data to something visual, right? So we derive something called tortuosity and map it to the curvature of this glyph. That's the amount of curvature that the player generated when they ran with the ball. The territory start position can be mapped to radius. The contour color is the team identifier, so each team has its own color, right? The net lateral movement is indicated with an arrow, this arrow, right? The number of phases is indicated just with a number. The direction is indicated also with this arrow. And the type of event is indicated with a pictogram in the middle. And then gain is mapped to the inner color. So that's just an example. Here's an example of that software in action. I know the suspense is agonizing. You can't wait to see what this is going to look like. I can't wait to see either. So we can immediately get an overview of all the events in the game in just a few seconds. So this is one game, all the events in one game, and we can see them all in just a few seconds on a scatter plot. This is the time along the x-axis at which the event occurred, and this is the amount of gain on the y-axis, right? So we can see, for example, a type of event with a very high gain, but no try. And we can sort the events, so these are all the line-out events, and we can see, oh wow, there were a lot of tries that resulted from line-out events, right, which is very interesting. Tries in this case are indicated with these purple halos, right? And we can make that observation in just a few seconds without having to watch the whole game, right? And we can sort by any property of those glyphs, like the time at which the event occurred, the amount of gain, the type of event that occurred, the number of phases, for example, and so on. It doesn't matter which attribute we choose, we can sort by any of them. This is a visualization of time versus the number of phases. So you can see right away, okay, the tries are associated with high numbers of phases, right? And we can can start to analyze the events. We can look for patterns. We can look for trends. We can look for outliers in an interactive visualization. And it doesn't take very long. And we can make observations quickly that we might not even be able to make at all just watching a rugby game, watching a video of a rugby game. We can also click, by the way, we can click on a glyph and then watch the video of the event. So a window pops up and then the original event is shown in the video. So in the interest of keeping with the schedule, I won't go through all of the details, this whole video. There's a copy of this video on my webpage. There's also a copy of this video with voiceover on YouTube, if anybody's interested in finding out more about that. And just before we wrap up, a quick mention that we do have impact, so to speak. We don't hide in the ivory tower all the time, so only sometimes. Our work does have impact beyond the walls of this building. So you can see the result of our visualizations, for example, in the New Scientist. This is one of our visualization projects. This is just one example. Here's another example at computerweekly.com. But if you're looking out for these things, if your radar is trying to look out for these things, you can find Swansea University Computer Science anywhere you look. We're in the BBC sometimes, you name it, the New Scientist and so on, the South Wales Evening Post. We've been in all the major media outlets. So thank you for your attention, and I'm happy to answer any questions if anybody has any. I think you're all thinking about the next rugby game. Can't wait to find out if Wales wins or not.